Hi, myself Dr. B. M. Palve, Assistant Professor, Department of Physics, Sangamner College, Sangamner. Today we are going to discuss the Newton's laws of motion. This is a very important topic from classical mechanics. The scientist Isaac Newton, who developed these Newton's laws of motion, and the first law is also called as a law of inertia. We know that this law indicates that without applying any force, body is in the state of rest or uniform motion. Therefore, it is also called as no force law. This law states that every body continue to be in a state of rest or uniform motion unless it is acted by external force on it. Means without applying any force, body is in the state of rest or uniform motion, means body is not accelerated. Okay, acceleration is 0. This is also called as a law of inertia. And what is by the inertia? The property of an object which resists the change in motion is called as a inertia. So this body is moving, but this is a uniform motion, means we are not applying any force. Okay, so what are the basic things of this Newton's first law? Net force is 0. We are not applying any force. Acceleration is 0. Particle is moving in uniform motion. It has uniform velocity. So acceleration is 0. Velocity may be 0 or may be constant. Okay. Object may be stationary or uniform in motion. The net force action on this particle is 0. So therefore, this law indicates the particle having no acceleration. Second law. This second law means in the first law we are not applying any force on the body, but in the second law we are applying the force on the body. So when we apply the force on the body get accelerated. Velocity of that body get changes. When the velocity get changes, there is some acceleration takes place. When the acceleration takes place, means how much force acting on that object or body is F is equal to mass into acceleration. So here we are applying the force. When we are applying the force, velocity of that body get changes, means acceleration takes place. When you apply the force, body is moving upward direction, its velocity get changes. So the second law states that the time rate of change of momentum of the body is proportional to external force and it is in the direction of the force. Okay, means the rate of change of moment of the body is directly proportional to the applying force. Okay, the acceleration and momentum, whatever the acceleration and momentum of the body takes place, is totally depends on how much force which acting on that body. That is F is equal to ma. F is equal to, acceleration is nothing but the rate of change of velocity, m dv by dt. So what are the basic properties of this second law? The net force is not equal to 0. The acceleration takes place and the direction of accelerated body is in the direction of applying force. F is directly proportional to the dp by dt. We know that momentum is nothing but the mass into velocity. If we put the value of the momentum here, we get the change of this momentum with respect to dt, with respect to time. But when we consider the relativistic case, the mass of the body can changes. That times the mass of the, when we consider the microscopic view or microscopic particles, the velocity of that particle is comparable to the velocity of the light. That times mass can changes. So for in case of relativistic, this is applicable for the relativistic case. F is equal to m dv by dt plus v dm by dt. But if the mass remain the constant, it means dm by dt is equal to 0. And finally, if dm is equal to 0, then F is equal to ma. This is applicable for only non-relativistic case. And this force m dv by dt plus v dm by dt, this is applicable for relativistic case. It means the velocity of that particle or particle is comparable to the velocity of light. Okay, so second law indicates the how much force, when the body is accelerated, how much force acting on that body. Okay, we all are aware about the gravitational law or gravitational force. When the gravitational force acting on the body, and that force is nothing but the F is equal to mg. G is acceleration due to gravity, which is remain the same, but that gravitational force is totally depends on the mass of the body. Okay, when the mass of the body is more, that gravitational force which is acting on that object is more. So this is the second law of motion. What is the third law of motion? Third law of motion states that to every action there is equal and opposite reaction. It means this is this indicates the pair of the forces which acting on the body. When two body interact with each other, these two body apply the force each other, which may be equal but direction is opposite. Okay, this is action reaction pair. This is action reaction pair takes place. We can see here the action reaction pair. When this ball is moving downward, when this ball bombarded on this other ball, action takes place, and its ball going backside, the reaction takes place. Okay, this is a very good example, that is the rocket motion. Okay, these gases which come outside come downward and the thrust develop upward. This is a good example of the Newton's third law of motion. So what are the rules of action and reaction pair? The first rule is the action reaction pairs always act on different body. When one body interact with the another body, action takes place, reaction takes place from the other body. Means this action reaction pair takes place for the different bodies. Second one, it should be same in nature. They have same nature, and every force always exists in pair form. Okay, means when we throw the ball on the wall, when the ball is bombarded on the wall, the action takes place, and ball return back, there is a reaction takes place. Okay, so what are the application of the Newton's law? The very good application, this is projectile motion. It's a good example of the Newton's law, and this is a rocket motion, is a good example of the Newton's law. And we know that the planet which are moving around the sun, when this planets moving around the sun in circular orbit, or whatever we can say the elliptical orbit, there is a centripetal force, and this force and this motion, these are the good examples of the Newton's first, second and third law of motion. Thank you.